So hello everyone, this is your maths buddy, and this is my first video. And in the coming times, I'll be uploading videos on the solutions of questions that were asked in mathematics in like your JEE Advanced or JEE question papers. So today we are gonna solve a JEE Advanced 2024 question. It was asked in paper one. So basically, let me read the question first. Let f be a continuously differentiable function on the interval 0 to infinity, such that f of 1 is 2, and this limiting term was given to you. Limit t tends to infinity, uh, t raised to power 10 multiplied by f of x in minus x to the power 10 f of t upon t to the power 9 minus x to the power 9 is equal to 1. X was greater than 0, and it has asked for all x greater than 0 if of x is equal to. So this question is a multiple choice question, and one of exactly one of the four options that were given to you was correct. So first of all, let us understand the nature of this problem. So this problem is uh, based on the concept of LH rule. LH rule. This problem, this problem is based on LH rule, and as you go on solving further, you will find ODE involved in it. You'll find ODE involved in it, and so first of all, just whenever you see any question in your J paper, J Advanced or J Mains, just don't go upon the length of the question. Okay, just try to read that question very carefully at first, and sometimes it may happen that the IITs may give you the questions intentionally lengthy, so a person who is not sitting in the examination with a calm mindset may lose the calm and just think like presume that question to be very difficult and just leave it over, and like and that question might be easy, but you will just not go on solving it, and then you'll lose your marks there. Okay, so let us start solving the problem. I have written down all the crucial things that were given in the question and what were asked to find. So that is f of 1 was given to be 2, and I've written the limiting term. So our target was finding f of x. So let me first write down the limiting term. So it was t to the power 10 f of x minus x to the power 10 f of t. Sorry, I have mistakenly written it x here. So it is f of t divided by t to the power 9 minus x to the power 9 is equal to 1. So let us first work upon the left hand side. Okay, let us first work upon the left hand side. Limit t tends to x, t to the power 10 f of x minus x to the power 10 f of t divided by t to the power 9 minus x to the power 9. So just first it's like it is very crucial thing to observe that the limiting term was given for the variable t. Okay, so you can just observe this thing here, that the variable term was t and not the x. So see, because the variable term is t and not the x, but this term here it was given like in terms of t and x. And see, in exam pressure we may just we may just forget this thing while calculating that what was the variable term. One may rather just like because after, like, as t tends to x in this expression, and the form that we will be getting here is like x to the power 10 f of x minus x to the power 10 f of x upon x to the power 9 minus x to the power 9. So this term is like 0 by 0, 0 by 0 form, and that is what we call as indeterminate form, right? This is an indeterminate form, right? And because this is an indeterminate form, and so here our procedure is like applying the LH rule. But as I said of the variable term is t and not the x, and this expression involves like a t and x. So in exam pressure, one may just forget what was this limiting term and rather use or rather apply LH rule, considering x to be the variable, x to be variable term. Okay, so this happens, and this has happened actually. Like there were my younger friends who did attempt this JEE Advanced question the last year, and they just told me like in the exam pressure they just they just applied the LH rule in the wrong way. That is, they used x as the variable term. Okay, so just check care of this simple thing, and because it came out to be an indeterminate form, so we are going to apply the LH rule, right? So after applying the LH rule, what we will apply LH rule taking t as a variable term, and then we'll get it as t a 10 times t to the power 9 f of x minus x to the power 10 f dash t upon 9 times t to the power 8 minus 0. See, because the variable term was t and not the x, so while applying the LH rule, x is just gonna act like a constant term. X is not gonna make any move here, so it's just gonna act like a constant term, and our main target was t because t is going to be the variable term, right? So while applying the LH rule, we're gonna apply it on t, and x is gonna just like act as a constant term, and that is why when I applied the LH rule, I just it came it the differentiation was applied on the t term, right? So it got like t 10 times 2 to the power t to the power 9 f of x minus x to the power 10 f dash t upon 9 times t to the power 8, and because I said of x is going to act like a constant term, so it came out to be 0. Okay, so now because see, you can just simplify this term, right? You may just simplify this term. Let me write it properly. 10 upon 9 t to the power 9 upon t to the power 8 f of x minus x to the power 10 upon 9 t to the power 8 f dash t, right? So further simplifying more, limit t tends to x 10 by 9 t f of x minus x to the power 10 upon 9 to the power 8 f dash t. Okay, and because now observe that if you like because t is tending to infinity in this term, because t is tending to x in this term, and this term won't come out to be an indeterminate form here. So you may just apply the limiting term, and it will be x f of x minus x to the power 10 upon 9 x to the power 8 f dash x, correct? So it will be 10 upon 9 x f of x minus x square upon 9 f dash x. So finally your left hand side came out to be 10 upon 9 x f of x minus x square upon 9 f dash x, and because your RHS is given to be 1, and because LHS is equal to RHS, because your LHS equal to RHS, because the LHS equal to RHS, so that is why our term came out to be like this. Okay, so now to proceed further, to just keep the thing simple, you may just take f of x to be y. See, because f of x is nothing but a function of x, right? It is nothing but a function of x, and we may just treat as to be a variable y that depends upon x. So in simpler words, just treat f of x to be y. Okay, if you do this, then you're gonna get 10 by 9x times y minus x squared upon 9 x squared upon 9 dy by dx is equal to 1. Correct? And to simplify further, you may just multiply both the sides by 9. By doing so, you will get 10 times x into y minus x squared dy by dx is equal to 9. Is that correct? So okay, I hope you are getting all the steps till this point. Okay, so now you may just divide both the side by x squared. So by doing this, you'll get x by upon x squared minus x squared upon x squared dy by dx equal to 9 by x squared. Okay, so this will further simplify to 10y upon x minus dy upon dx equal to 9 upon x squared. Okay, so I hope you all are with me till this moment. So just simplify this term further. Between so you will get it as dy by dx minus 10y by x is equal to minus 9 upon x squared. So how did we get it? Multiplying both the sides by minus 1. Okay, so now this is a linear differential equation of first order, right? And we solve it by the method of integration factor. So the general formula for finding an integrating factor for a linear differential equation of this form, so general form is dy by dx plus py is equal to q. This is general form of linear differential equation of first order, right? And to solve it by the method of integrating factor, the general formula for integrating factor is e to the power b dx, right? And then we just solve. After we get this integrating factor, we solve the differential equation y integrating factor is equal to q times integrating factor dx plus c. We solve this differential equation and finally we get y, right? we get y as a function of x. So the similar thing, we are going to apply this generality to our problem. Okay, so comparing, you must see that p is equal to minus 10 upon x, right? You may compare, this general form and are given like the equation, the linear differential equation we arrived at, right? So you may compare these two things and you may see p to be minus 10 upon x. So it implies our integrating factor to be e to the power minus 10 upon x dx, right? And it will come out to be e to the power minus 10 ln x, right? So you will get it as 1 upon x to the power 10, right? So therefore integrating factor came out to be 1 upon x to the power 10, right? So just let's like then we'll solve this equation now. Like we can compare these two things, put our substitute our integrating factor and the value of q in this general form, and we may now simply solve this equation. So then we'll get our different we'll get our solution to be like this, right? And then simply you have to solve here, and so it will be minus 9 upon x to the power 12 dx plus c. By then here by solving this simple integration, we'll get it to be x to the power minus 12 plus 1 upon minus 12 plus 1 plus c, or it is 9 upon 12, sorry, 9 upon 12 minus 9 upon minus 11 x to the power minus 11 plus c, and this is nothing but y multiplied by 1 upon x to the power 10 is equal to 9 upon 11 x to the power minus 11 plus c. And so y equals 9 upon 11 x to the power minus 11 x to the power into x to the power 10 plus c times x to the power 10, and you may simply solve it here. X to the power 9 upon 11 multiplied by x power minus 1 plus c x to the power 10, right? So this is your y, because it was given that it was given that f of 1 is equal to 2, and since we have substituted y, or we have substituted y as y as f, so it implies y of 1 is equal to 2. And just simply keep these values in your this equation. You will get 2 is equal to 9 upon 11 1 to the power minus 1 plus c 1 to the power 10, and it comes out to be 9 upon 11 plus c. So you will get 2 minus 9 upon 11 is equal to 22 minus 9 upon 11, and it is nothing but 13 upon 11. So the value of arbitrary constant c comes out to be 13 upon 11. So simply keep this value in the equation you got here. So it will be 9 upon 11 x to the power minus 1 plus 13 upon 11 x to the power 10. And just resubstitute, substitute back your y. So it will be f of x is equal to 9 upon 11 x to the power minus 1 plus 13 upon 11 x to the power 10. It is nothing but 9 upon 11 1 upon x plus 13 upon 11 x to the power 10. So this is your f of x. So seeing the options, option B was correct, right? You must have observed that the solution for this problem, it was a kind of bit lengthy. Okay, but if you have a good practice, if you have good practice and the like so seeing the options, option B came out to be correct, right? So you must have observed that the solution for this question was a bit lengthy, right? But if you have good practice and a habit of reading the questions properly, like solving this question wasn't really like it would have taken you 5 to 7 minutes, right? But not more than that, in case you have a good practice, right? So I hope you liked the video. I think I might have done some mistakes while making this video, or writing. Like I must have done some mistakes while making this video, but I will just go on doing better and better the next times. So don't forget to like and subscribe. Thank you.